welcome to this video. So this video will solve basically questions on work, energy and power. So before we start solving the questions, you need to understand some terms and some formulas which we can use on what? On work, energy and power. So before I start, don't forget to hit the subscribe button and comment for more videos. So what do we need to know under work, energy and power? So basically this is the simplest topic. It has simple formulas which you can memorize even in one day. So to begin, we are looking at work. So what exactly is work? So work is simply the product of force and distance moved in the direction of force. So what do we mean when we say work is just a product of force and distance moved in the direction of force? So in simple terms, work is simply how we spend what? Energy. So when you do work on an object, means you yourself, you are transferring energy from your body into the object. So there are two scenarios. So there are basically there are basically formulas which you need to know. So work is given by the formula work is equals to force multiplied by distance. So this is our formula for what? For work done. But in the case where we don't have the force, but we have been given the what? The mass. If you don't have the formula, if you don't have the force, you have been given the mass, you can also calculate the what? The work done. So when you don't have the force, the work done is equal to the potential energy, as we will see as we progress. So our first question, which says, how much work is done in getting the what? The blocks to the top of the building. So the question is saying, a crane lifts blocks through a vertical height of 24 meters with a force of 500 newtons at a constant speed of 6 meters per second. It takes 4 seconds to reach the top of the building. How much work is done in getting the block to the top of the building? So as I told you, work is equals to force times distance. So basically this question was simple. So just pick this will be our distance and this will be our force. So our first question, force is 5,000 newtons multiplied by the distance, which is 24 meters. Then this, if you punch on the calculator, you'll find that we have 120,000 joules. So this same number, they can tell you to convert it into what? Scientific notation. Sometimes they can say, or leave your answer in scientific notation. So how do you leave your answer in scientific what? Notation? So you basically count. Here is where the point is. So you say 1, 2, 3, 4, 5. So you say in standard notation we have 1.2 times 10 to the power 5 joules. So this is our work done. which is 120,000 joules, or 1.2 times 10 to the power 5 joules. So this is how you can calculate what? The work done. Yeah. So now we move on to energy. Yeah. So on energy, you need to pay very much. Pay attention. Yeah. So we are looking at now energy. So what is energy? So energy is basically defined as the ability to do work. So energy is the ability to do work. Yeah. So for you to push that object, of course you need some energy that you convert into that what? Object. So that's why energy is the ability to do what? Work. Then energy basically has two types. We have what is known as the potential energy, which is the energy an object possesses at rest. Energy an object possesses at rest. So basically, when an object is not moving, it has what is known as potential energy. So how can we calculate our potential energy? So potential energy is calculated by potential energy is equals to mass times the gravitational field times what? Height. Yeah. So this is our formula for potential energy. Now getting back to the question, which says, what is the potential energy gained by the blocks? So here they want us to calculate now the potential energy which the blocks gained. Yeah. So remember, I told you potential energy is equal to what? Work done. Yeah. So since potential energy requires the mass and what? The gravitational field. But remember, we have what? Force. So this force is the same as mg. Mass times the gravity will give us force. Yeah. So force is equals to mass times the acceleration. Everybody knows this formula. So if we don't have the mass and the what? The gravitational field, we can replace both this formula with what? With F. So therefore our formula is force times height. Our force we have is 500 newtons, 5,000 newtons times our height, which is 24, which gives us again 120,000 joules. Yeah. So the potential energy is equals to 120 joules. Yeah. So this is how physics questions are simple. Yeah. So now that we have looked at the potential energy, we are going to look at what? The kinetic energy. Yeah. So what is the kinetic energy? So the kinetic energy, this is the energy an object in motion possesses. So meaning when an object was at rest, but due to some external force it starts to move, that potential energy will be converted into the kinetic energy because the object is moving. Yeah. Then the formula for kinetic energy is equals to half mass times velocity squared. So this is the formula we use to calculate what? the kinetic energy. Yeah. So saying that concludes our energy. So energy is the ability to do work. We have two types of energy. We have the potential energy, which an object possesses at rest. When an object is not moving, it has the potential energy. Then when you talk about the kinetic energy, this is just the energy an object in motion possesses. Once the object starts moving, it possesses a certain type of energy which is known as the kinetic energy. Yeah. So now before we move on, there is one diagram I want you to understand. I like bringing it. So we have three scenarios. We have first, this boy is holding the ball. Then second, at the middle. Then last, before it hits the ground. So here, when the boy is holding the ball, meaning the ball has what? Potential energy, because the ball is not moving. So for the sake of teaching, I'll use 1000. So let's say here we have the potential energy, which is equals to 1000 joules. Then the kinetic energy is what? 0. Because the object is not moving, you are holding the ball. So meaning the kinetic energy is 0. But immediately you drop the ball starts gaining what? Kinetic energy, and potential energy starts to reduce. So you need to pay attention. Once you drop the ball, the potential energy starts to decrease and the kinetic energy starts to increase. Then once the ball reaches the midpoint, the potential energy and the kinetic energy are the same. So we have 5,000, 500 and 500 joules. So you are wondering, where is this 500 joules is coming from? So remember, the potential energy is reducing as the ball is going down, whilst the kinetic energy is increasing. So at the midpoint, both the potential and the kinetic energy will be the same. Yeah. Then lastly, before the ball hits the ground, here the kinetic energy now is maximum. So meaning here the potential energy will have is 0 joules. Then the kinetic energy will be 1000 joules. Yeah, so you need to understand this conversion. This is known as energy conservation. Energy is neither created nor destroyed, but transferred into another form. Yeah, so we can see here the potential energy is being converted slowly into kinetic energy. Yeah, so now moving on to our final part, which is the power. So the question is saying calculate the power developed by the blocks. Yeah, so our next is the power. So what is power? So power is defined as the rate of doing work. So power is just the rate of doing work. Yeah. So this is the last formula which you need to know on work, energy, and power. So power is the rate of doing work. Yeah. So now you're asking yourself, what is the formula for power? So the formula for power, as we said, it is the rate of doing work. So meaning in the formula for power, we are expecting to find work. And since it's the rate, we should also find what? Time. So whenever you hear something having rate, meaning time is involved. Yeah. So power is given by the formula work done divided by time. Or in some cases, power is given by energy. or the potential energy divided by time. So you need to know these two formulas. Yeah, on power. Yeah, then for the formula for work is equals to force times the distance. So these four formulas are very, very important for you to pass this exam and to solve these questions. Yeah, so the question is asking us calculate the power developed by the blocks. So how can we calculate the power developed by the blocks? So we said that power is work done over what? Time. So since work done we calculated in the first question, which was 120,000, we are going to just replace. So you say power. So you say power is equals to work divided by time. Then the work we have is what? 120,000 joules divided by the time, which is 4 seconds. So if you divide 120 divided by 4 seconds,